Hello, this is Deborah Barrett with the Cincinnati State Physics Department presenting vectors versus scalars. A vector is a quantity with magnitude, that's size, and direction, as opposed to a scalar, which is a quantity with magnitude only, that's a quantity with no associated direction. As a first example of a scalar, we have distance. Distance is the length of the path that an object travels. Direction is not incorporated in the physics definition of distance. So, distance is a scalar. Displacement, on the other hand, means the change in position, including direction. For physics people, displacement is explicitly defined to include direction. So, a vector would be displacement, or displacement would be a vector. Additional examples. Speed. For physics people, speed means how fast an object moves. So, on average, speed is equal to the distance divided by the time. There is no directionality in that definition. Distance doesn't have direction. Time doesn't have direction. Speed is not defined to incorporate direction. So speed is a scalar, not a vector. On the other hand, velocity, you can think of it as speed in a certain direction. Average velocity is calculated by taking displacement divided by time. Displacement incorporates direction, which makes sense because velocity means speed in a certain direction. Another example would be acceleration. I'd like to suggest you take a moment, pause the recording, and decide for yourself whether you would figure acceleration is a vector or a scalar. Now that you've thought about it, I hope you've decided that acceleration seems like a vector, since acceleration means how fast velocity changes, and velocity includes the concept of direction, then acceleration also needs to include the concept of direction. Acceleration can be calculated by taking the change in velocity divided by time. Since velocities have directionality, then the change in velocity has directionality. So, looking at it that way also, acceleration is a vector. It will have directionality. Another example for you to pause and decide is force. Please take a moment, pause the recording, jot down whether force is a vector or a scalar, and I suggest you also jot down your reasoning and then restart the recording to hear what I would say about that. Okay, so you've made your decision. Hopefully you have decided that force has an associated direction. You know, I think, that force means a push or a pull. Since every push or pull inherently has to have a certain direction, that means that force inevitably is a vector. Our next example would be time. I'm going to request that you pause the recording and jot down your decision about whether time is a vector or a scalar, along with your reasoning. Okay, I hope you've made your decision about time. Time can only go forward. Having just one direction is not enough to establish something as a scalar. So instead, time is a vector. Excuse me, it's not enough to establish a quantity as a vector. So time is a scalar. Even if time could actually go backwards, two possible directions forward and backward is not enough to establish a quantity as a vector. In order for something to be a vector, it has to have multiple time possibilities. I hope this set of examples has clarified the meaning of vector versus scalar for you. I would also like to suggest, if you have not already reviewed the kinematics videos that are on Blackboard, that you do that at this point. And thank you for reviewing vectors versus scalars.